Good morning, everyone, and thank you for joining us today. In this discussion, we will explain Google Cloud, its architecture, and its ecosystem analysis. Now, to really get a grip on what Google Cloud is, we have to look past the flashy product pages. We need to see it for what it truly is. We're not just talking about another cloud provider, we're talking about the public-facing evolution of an infrastructure that was literally built to solve problems on a global, planetary scale. To really understand Google Cloud, you've got to go back. For decades, Google has been tackling engineering challenges at a scale that, honestly, very few companies on Earth have ever even attempted. I mean, think about it. Indexing the entire internet for Google search or streaming billions upon billions of hours of video on YouTube. The systems built to handle that kind of load, well, that's the DNA of Google Cloud. And that's really the core question, isn't it? How do you take these incredibly powerful, battle-tested internal systems that were designed for just one customer, Google itself, and safely, securely slice them up for the whole world to use? This wasn't just about flicking a switch and calling it a day. It required solving some immense engineering puzzles around multi-tenancy, security isolation, and making sure everything just works globally. And the result of solving all those hard problems is this really powerful idea. So try not to think of Google Cloud as just renting some servers somewhere else. The best way to think about it, the right mental model, is to see it as one single unified computer that spans the entire globe, and you can program it. This idea is absolutely the key to understanding its architecture. So, okay, with that global computer model fresh in our minds, let's lay down some groundwork. Before we get into all the specific Google services, we really need to understand the basic models of cloud computing that everything else is built on. This is the first, and maybe most fundamental choice every developer makes when they move to the cloud. You can think of it as a spectrum of control versus convenience. How much of the nitty-gritty underlying tech do you want to manage yourself, and how much do you want to hand off to the provider so you can just focus on your code? Okay, so if you look at this chart, way over on the left, you've got your traditional on-prem setup, where you do everything. Now, take one step into the cloud with IaaS, or Infrastructure as a Service. Here, the provider handles the physical data centers, the servers, the networking, but you're still in charge of the operating system, the runtime, and your app. Move one step further to the right to PaaS, Platform as a Service, and the provider takes on even more. You just bring your application code, and they handle scaling and the OS. And finally, on the far right, you have SaaS, Software as a Service. Think Gmail. You just use the software. Google Cloud has offerings all across this spectrum. So now that we have those concepts down, let's see how Google actually builds this global computer. What does the physical and logical blueprint of the platform actually look like across the planet? The physical foundation is all built on regions and zones. A region is a big, independent geographic area, say US Central 1. But here's the key. Within that region, there are multiple zones. Think of a zone as an isolated building, a single fault domain. So by spreading your application across multiple zones within a single region, you can build incredibly resilient systems that can literally survive an entire data center going offline. This is the bedrock of high availability on GCP. So if regions and zones are the physical map, this hierarchy here is the logical structure you use to organize all your work. At the very top, you've got your organization, that's your company. Under that, you can use folders to group things by department or team. And right at the center of it all, you have projects. And I really can't stress this enough, the project is the absolute fundamental unit of organization in GCP. Every single thing you create, a virtual machine, a database, a storage bucket, you name it, must belong to a project. It's the container that holds everything together: billing, permissions, APIs, the whole shebang. All right, we've covered the physical layout and the logical organization. Now let's pop the hood and take a look at the engine room. What are the core philosophies and technologies that really make Google Cloud Services tick? This is where things get super interesting from a computer science point of view. These three principles are pretty much the soul of GCP's architecture. First, a strict decoupling of storage and compute. This is a total game changer. It means you can scale your processing power completely independently from your storage. You can spin up a massive compute cluster for just a few hours to chew through petabytes of data and then spin it all down without ever having to move that data. It's huge for big data and ML. Second, software-defined networking means the whole network is programmable and incredibly flexible. And third, a zero-trust security model, which basically operates on the principle of never trust, always verify. Every single request is authenticated and authorized.
You know, you can't really talk about modern cloud without talking about Kubernetes, and its origin story is just fascinating. It didn't just appear out of thin air. It's the result of over a decade of Google's experience running containers at an unimaginable scale. It started with Borg, the internal system that runs pretty much everything at Google, from search to Gmail. Then came Omega, its successor. Kubernetes took all the best ideas, all the hard-won lessons from running billions of containers a week, and gifted them to the world as an open-source project. So let's talk about serverless security for a second. In a multi-tenant world like Cloud Run, how do you keep everyone's containers safely isolated without the performance hit of a full virtual machine? Well, Google's answer is a brilliant piece of engineering called gvisor. It's basically an application kernel that sits between the container and the host operating system. It cleverly intercepts system calls and handles them securely in user space, giving you the strong isolation of a VM, but with the lightweight speed of a container. It's awesome. Okay, choosing the right database is absolutely critical, and this table breaks down the main options really well. For your standard traditional applications, Cloud SQL gives you that familiar relational database. For modern web and mobile apps that need flexible data, Firestore's document store is perfect. But for massive scale data ingestion, like from IoT devices, you've got Bigtable. It uses a log-structured merge tree architecture, which is a fancy way of saying it's optimized for incredibly fast, high-volume writes by making everything a sequential append. It's exactly what those workloads need. So what kind of network do you need to tie all of this incredible infrastructure together? Well, something absurdly fast. This number, 1 petabit per second, is the bisection bandwidth of Google's Jupyter Data Center network. That's 1,000,000 gigabits per second. This massive internal capacity is what makes things like decoupling storage and compute even possible. It's what allows for those giant ML jobs that shuffle petabytes of data around. The network is, without a doubt, a huge competitive advantage. Okay, so we've seen the raw power and we've looked at the individual components, but if you're an architect or a developer sitting down to build something, how do you actually choose where to run your code? Let's walk through a really simple but powerful decision framework. This is it. This is the first, and honestly, the most important question you have to ask yourself. It's that classic trade-off between control and convenience. Do you really need to get in there and fine-tune the operating system kernel, or would you rather just focus on writing your business logic and let the platform handle all the rest? And this choice is perfectly illustrated when you compare Compute Engine and App Engine. On one side, you have Compute Engine. That's pure IaaS. You get a raw virtual machine, maximum control. It's perfect for things like lifting and shifting an old application. On the complete other end of the spectrum is App Engine. It's a fully managed, serverless PaaS. You just give it your code and Google handles everything else. Scaling, security patching, you name it. And here's the second critical question, especially in today's multi-cloud world. How important is it for you to avoid being locked into a single provider? Do you need the freedom to run your applications on-premise, or maybe even on another cloud provider if your strategy changes? This is where GCP's deep commitment to open source really shines and gives you a huge advantage. Google Kubernetes Engine is, of course, built on open source Kubernetes. Cloud Run is built on Knative. Cloud Functions uses an open fast framework. So by building on top of these open standards, you're not just adopting a Google Cloud service, you're adopting an industry standard technology that you can run pretty much anywhere. This gives you incredible strategic flexibility. We have covered a lot of ground, all the way from the foundational IaaS, PaaS, SaaS models to the nitty-gritty of services like gvisor. So let's just pull back for a second and summarize the most important takeaways. What's the big picture you should walk away with? This quote really says it all. If you only remember one thing from our discussion today, let it be this. The real power of Google Cloud comes to life when you stop seeing it as just a collection of servers and start seeing it as a single, cohesive entity, a computer that spans the entire planet, ready for you to program. At the end of the day, to really understand Google Cloud, you have to appreciate its deep, deep roots in decades of distributed systems engineering. The pattern we've seen over and over is that these battle-hardened internal systems, like Borg, are constantly being refined, productized, and then released as open, powerful services for everyone, like Kubernetes. This whole evolution points in one direction, making the immense complexity of infrastructure just disappear, so that you can focus on building whatever comes next. Thank you so much for watching. If you enjoyed this, please subscribe, like, and share. And don't forget to hit the bell for more from Tech, AI, and beyond.